Dear learners, welcome again to the engineering chemistry course. Before starting today's lecture, just revise what we have learned in the previous class. In the previous class, we have learned about the secondary solid fuel, coke, carbonization process, The coke is formed by the carbonization process that we have learned in our previous class, and the carbonization process is of two types based upon the carbonization temperature. Low temperature carbonization, which is carried out at 500 to 700 degrees centigrade temperature, while the high temperature carbonization, which is carried out at 1000 to 2000 degrees centigrade temperature. Then we have learned about the manufacturing of the metallurgical coke by beehive coke oven method. This we have discussed in detail in our previous lecture. Now, in today's class, we are going to discuss about the manufacturing of metallurgical coke by Otto Hoffmann's oven method, in which we will discuss the construction and the working of the Otto Hoffmann's oven and the recovery of the byproducts, useful byproducts in this method. In the last class, we have learned that the main drawback of the beehive oven method is the non-recovery of the useful byproduct, but this drawback can be overcome in the Otto Hoffmann's oven method. So let us begin with the Otto Hoffmann's coke oven method. This is the construction diagram of the Otto Hoffmann oven. The Otto Hoffmann oven consists of a number of narrow silica chambers. These are the narrow silica chambers. These separated by the interspaces for burning the gas. Each silica chamber is about around 10 to 12 meters long, 3 to 4 meter high, and 0.4 to 0.45 meter wide. Each chamber is provided with the charging hole here. Each silica chamber is provided with the charging hole at the top, a gas off tape and refractory lined iron door at each ends of the discharging of the products. One single oven is capable of holding around 16 to 24 ton of coal. A battery of such oven is placed over the regenerators having the checker brick. This regenerator having the checker brickwork, which helps in utilizing the heat of the flue gases. So this diagram is the detailed of this part. This is the narrow silica chamber part, in which various silica chambers are placed in the Otto Hoffmann's method. In this way, various silica chambers are placed. Each silica chamber is closed with the upper lid, and this upper lid is connected with the coal charging tower here. So this is the basically Otto Hoffmann's detailed Otto Hoffmann oven, in which at the uppermost part where there is the coal bunker. This coal bunker where the coal is collected. So we introduce coal in the core bunker. Beneath the coal bunker there is the coal charging tower where the coal is activated here. Through coal bunker, coal is get into the coal charging tower where coal is get activated. Each coal charging tower is connected with the silica chamber. In this way, collected with the silica chambers. So the coal from the coal charging tower is now moved towards the silica chamber. These silica chamber are the airtight silica chambers. No air is provided in these silica chambers. Now, clear? So finally, now through this finally crushed coal is introduced to the top charging hole to the silica chamber here. From this way, these holes are then closed tightly to cut off the air supply. The oven are heated to 1200 degrees centigrade by burning gaseous fuel. Now, from where the gaseous fuel comes here, look at here in this figure, we can clearly see air and producer gas mixture is passed through this channel. Producer gas is the gaseous fuel. In presence of air, the producer gas burns here. In this part, combustion of the gaseous fuel takes place. Through combustion, large amount of heat energy is released, which increases the temperature of the silica chamber. In this way, the heat energy increases the temperature of the silica chambers. Now, the silica chambers are started to heat up, and the waste gases released by the combustion of this producer gas coming towards this side. And when the gases coming towards the exit pathway, these gases gives their energy to these checker bricks. These are the checker bricks which absorbs the energy of the waste gases. So now the checker bricks are heated. Clear? So due to the combustion of the producer gas, silica chambers are heated, and at high temperature coal present under the silica chamber undergoes in carbonization process, and formation of coke started. This is the first step. The flow of heating of the flue gases. What are the flue gases? Flue gases are the waste gases. These waste gases are also called as the flue gases. F-L-U-E. Flue gases. These are the waste gases. So, first time the waste gases or the flue gases which are released by the combustion of the fuel gas, that is the producer gas, are coming towards this exit pathway. Clear? So the flow of heating flue gases is then reversed, and the inlet gases used for combustion are passed through the heated checker brick work of regenerators. What does it means? It means that first time the waste gases are released through this pathway. In the second time, we passed the gases from here. Clear? So in the first cycle, the waste gas is released from this pathway. When these gases are released from the oven, these waste gases gives their energy to these checker bricks. Now the checker bricks are heated up. So in the next cycle, the producer gas is passed through this, and this producer gas gain the energy of the checker bricks, and this energy which the checker bricks provided gives the ignition temperature to the producer gas. So basically this checker bricks works on the regeneration of the heat economy. The energy of the waste gases is utilized to provide the ignition temperature to the producer gas. I hope it is clear to all of you now. Thus, the regenerator work on the principle of the alternate heating and cooling cycle. How heating and cooling cycle? When the waste gas is released out, these energy heated up the regenerator. In the next cycle, when producer gas is passed, these producer gas gains the energy from the checker bricks. So the checker bricks are again cooled down due to the combustion of producer gas. When energy is released and waste gas is again coming out, so again they give the energy to the checker brick, and checker brick again heated up. So this is the cyclic pathway and the work on the heat economy. The heating of the oven is continued till the evolution of the volatile matter ceases completely. These are the silica chambers, main part of the oven, heated continuously. The process of carbonization takes place layer by layer on the coal charge, starting from the two side walls, because the heating is started from the side. So first the coal, these side layer are first heated, so carbonization takes place at this end first, side ends, and soon after the carbon layer present in the middle will undergo in the carbonization process. So layer by layer carbonization process takes place. The complete carbonization takes around 11 to 18 hours. If you remember, in beehive oven method it takes 2 to 3 days, while in Otto Hoffmann's method the process get completed only in the 11 to 18 hours. After the completion of the process, the red hot coke present in the silica chamber is then pushed outside by means of the ram, which is electrically driven. Here is the ram. This structure is the ram. By the pressure of this ram, the coke can be pushed outside. But before discharging the coke, the quenching is to be done. For the quenching, we may use the dry quenching or we may use the wet quenching. For the dry quenching, we know inert nitrogen gas is used, while for the wet quenching, water is used. That means spray of water can be done. So either dry quenching or the wet quenching may be used for the to stop the carbonization process, and then through the ram coke pusher, we can discharge the coke from the oven. But this is the coke discharging. But if you look at this structure here, all the silica chambers are connected through a gas pipe here. This gas pipe collects all the coke oven gases, which contains very useful byproducts. We know the basic carbonization reaction is this coal. In absence of air, when heated, it formed the coke plus mixture of various useful byproducts, which are called as the coke oven gases. So all these coke oven gases are now collected at top of the silica chambers. These silica chambers are interconnected. So all these silica chambers, the gases present in all the silica chambers get collected at the one point here. Now in this coke oven gas, there are various useful byproducts like tar, ammonia, naphthalene, benzene and its homologous compound, H2S, and the most important last product is the coal gas. So these are the various useful byproducts present in the coke oven gas, which must be separated from the coal gas so that we can obtain the coal gas as a gaseous fuel. So now coming towards the recovery of the byproduct in the Otto Hoffmann method. When the coke is produced and coke is recovered or discharged from this point, the coal gas is collected. Basically this is the mixture of various byproducts and called coke oven gas. This coke oven gas is collected and driven through the recovery plant. This is the recovery plant. As I just discussed, that the various useful byproducts are present in this coke oven gas. So the recovery plant contains various chambers to separate out all these useful byproducts. First is the recovery of the tar. The coke oven gas, this coke oven gas is passed through a tar in which a liquid ammonia is sprayed. Tar and dust collected in the tank. Through the liquid ammonia, all the tar get collected at the bottom of this tank and then separate out in separate tank, where due to the lighter weight, ammonia get evaporated and tar get collected at the bottom. Remaining gases pass to the next chamber. In the next chamber, which is the recovery of the ammonia chamber, the gases are then passed in the chamber in which water is sprayed to recover ammonia. Ammonia gas goes into this solution in the form of ammonium hydroxide with the reaction of the water. Removal of ammonia is necessary, otherwise it may cause blockage of the gas pipe in the form of ammonium carbonate. So with the help of water, all the ammonia get converted into ammonium hydroxide and collected at the bottom of the tank. Now the remaining gases passed through a cooling tower in which water at low temperature, chilled water, is sprayed in this. This chilled water, due to the spray of this chilled water, all the naphthalene present in the coke oven gas get condensed and collected at the bottom. Due to the condensation, naphthalene converted into liquid form and collected at the bottom. Remaining gases are passed through the next chamber in which petroleum oil or the wash oil is sprayed in this chamber. So all the light oil means benzene and its homologous compound, dissolve in the wash oil and get collected at the bottom of this chamber. The remaining gas contains impurity only, the H2S impurity. So to remove the H2S impurity, we pass the remaining gases through a catalytic chamber which contains iron oxide as a catalyst. This iron oxide absorbs the H2S in this way. And convert it into the iron sulfide and H2O. So all the H2S gets trapped into this catalytic chamber and iron oxide get converted into iron sulfide now, and the remaining gases, which is the pure coal gas, is collected out from this chamber. So basically this is the recovery plant in which tar is separated with the help of spray of the ammonia. Ammonia is separated as ammonium hydroxide with the help of water. Naphthalene is separated by the condensation reaction with the help of the chilled water. Benzene and its homologous compound are separated with the help of the wash oil or the petroleum oil, because petroleum oil dissolve all the benzene and its homologous compound, and which can collected at the bottom of this chamber. To remove the H2S from the remaining gas, iron oxide catalytic chamber is used. Iron oxide absorbs the H2S gas and convert into the iron sulfide. The gas coming out through this chamber is the pure coal gas, which can be collected separately. After some time, since the complete iron oxide is converted into iron sulfide, so regeneration of this iron oxide is necessary. So for this regeneration of iron oxide, we open this catalytic chamber and air is supplied. When air is supplied to this chamber, this iron oxide reacts with the oxygen and again converted into finally iron oxide. So it is generated and further can be used for further regeneration or the recovery process. So this is the complete recovery of the byproducts in the Otto Hoffmann's method. So what we have learned today, in the today's lecture, we have discussed about the manufacturing of coke, metallurgical coke basically, by the Otto Hoffmann's oven method, in which we have discussed that the main advantage of the Otto Hoffmann's oven method is the recovery of the all the useful byproducts, which are mainly ammonia, tar, naphthalene, benzene and its homologous compound, and most important the coal gas, which is the gaseous fuel. In detail, we have discussed the construction and the working of the Otto Hoffmann's method. We have learned that the 16 to 20 ton of coal can be converted into coke in a single Otto Hoffmann method. There is the coal bunkers which contains large amount of coal which can store the large amount of coal. The coal bunkers are connected with the coal charging tower in which coal is get activated. This coal charging tower is connected with the silica chambers in the oven part. These silica chambers are interconnected chambers and the airtight chamber in which coal is burned. To increase the temperature of the oven part, the producer gas is used. This producer gas burns in this part and release the energy. The energy released by producer gas is utilized for the carbonization process. The side product is released as a coke oven gas which is collected separately for the regeneration purpose. And for the regeneration purpose, various type of recovery plant is used in which various type of separating tar is used to recover the each byproduct. These tar, ammonia, naphthalene, benzene, H2S and finally coal gas, purified coal gas is recovered. So this is what we have learned in the today's class. Now it's time to learning check. Read the question carefully on your screen and think about the correct answer. To remove H2S from the coal gas, which catalyst is used? Fe2O3, FeO, Fe or HCN? Yes, you are correct. It is the Fe2O3. Just we have discussed it. Fe2O3 is used to separate out the H2S from the coal gas. So that's all about the today's lecture. Thank you. Take good care of yourself and keep enjoy e-learning at home. Thank you.